Welcome to Study Loop.
In this problem, we want to figure out what the moment of inertia of a combined system is. And so, to do that, we can sum the individual moments of inertia. So the total moment of inertia is the moment of inertia of the disk plus the moment of inertia of the ring. And then the moment of inertia of the disk is just 1/2 times the mass of the disk times the radius of the disk squared. And the moment of inertia of the ring is just 1/2 times the mass of the ring times r1 squared plus r2 squared, where the radii are given in the problem. These two forms I got from table 9.2, and they're one of the common forms of the moment of inertia. And so the next step is to figure out what the mass of the disk and the mass of the ring are. Well, the mass of the disk is equal to the density times the area. Well, the density is 3 grams per centimeter squared. It's given in the problem. And then the area of the disk is pi r squared. So pi radius of the disk squared. Now at this point, you have to be careful about units. We want the mass to come out in kilograms so that we can use it in this and get our standard SI units back, which means we have to be careful with this grams. We might want to convert it to kilograms. And we also have to make sure that the radius of the disk here is given in centimeters, so that when we square it, we get centimeters squared, and then it cancels with this unit here. In the end, if you make sure to plug in the correct values and do the unit conversions correctly, you'll get a mass of the disk equal to 23.56 kilograms. Plugging this into there, converting the radius of the disk into meters and then squaring it, I get that I disk is equal to 2.945 kilograms times meter squared. And so now we find the mass of the ring. So the mass of the ring is the same thing. It's the density, which is 2 grams per centimeter squared, times the area of the ring, which is pi, and then I have the larger radius squared minus the smaller radius squared. That's the area of a ring. Same thing here. You have to be careful to convert this grams to kilograms, and you have to be careful to use a radii values here of centimeters so that they cancel here. If you do this correctly, you should get a mass of a ring of 15.08 kilograms. And then plugging this mass into this formula along with the radii gives that the moment of inertia of the ring is equal to 5.58 kilograms meter squared. At this point, we have a value here, and we have a value here. So we simply sum them to get the total. When you do that, you get the total inertia, moment of inertia, is 8.52 kilograms meter squared. And that's the final answer.